Hello everyone, happy to see you here, welcome back to my channel. Today we have a great, quick and relaxing algebra question. We need to solve this equation for a, 3 to the a minus 2 to the a equal to 65. We need to solve this question for a, so if you have your solution, your answer, your approach, you can also write it in the comments below. It will be really interesting to read about it. Okay, so first of all, I want to use a really interesting and great trick. I want to create a difference of squares, so that's why instead of 3 to the power a, I want to write the next expression. I'm going to write square root of 3 to the power a and raised to the power 2. I want to write it like that. It changed nothing because we can easily cancel these two with this square root sign. And I'm going to do the same thing with 2 to the power a. So we have square root of 2 to the power a and raised to the power 2 equal to 65. Right now, everyone knows that we are talking about, if you're talking about power, square root is the power 1/2. So I hope you understand what I mean. It's the power 1/2. So that's why we can write this 3 to the power a as 3 to the power a over 2. Yeah, we can write it in this way. 3 to the power a over 2. We can write it like that. And raised to the power 2. And the same thing with this 2 to the power a. So 2 to the power a over 2 and raised to the power 2. Even though with this expression we can multiply a over 2, so we can easily write the same thing as in the beginning. So basically we change nothing, but in the same way we can consider this expression as a difference of squares. Yeah, we have, this is our first expression, for example, this is our x. These are our second expressions, this is our y, so we have x squared minus y squared, and everyone should know this classic school formula, x plus y, x minus y. Yeah, so let's do it. So we can write it as 3 to the power a over 2 minus 2 to the power a over 2, and 3 to the power a over 2 plus 2 to the power a over 2, but for further solution, I want to use, for example, x and y, or a and b, so I'm going to use, for example, x and y. So we have x plus y, x plus y, and times x minus y. So as I said before, we write, looks like a substitution, so that's why I want to underline this substitution right here. So 3 to the power a over 2, this is our x, and 2 to the power a over 2, this is our y. So we have our substitution. So that's why we need to consider a lot of different combinations. The first one, 1 times 65. 65 is not a prime number, so that's why we had to solve it for all the combinations. 65 times 1, the second combination. And the third one, we have minus 1 times minus 65. Yeah, we have a minus 65 times minus 1. We have the first combination. We have 5 times 13, 5 times 13. We have minus 5 times minus 13 times minus 13, 13 times 5, 13 times 5, and minus 13 times minus 5. And few really interesting moments, because this expression, if you're talking about x plus y, in the same way, this is our 3 to the power a over 2. Everyone knows that this is exponential function, so that's why this x need to be positive and this y need to be positive, because our exponential function is always positive. So that's why we reject a lot of cases. So we reject this case, we reject this case, this one, and this one. So we end up with 4 cases. So we have 1 times 65, 65 times 1, 5 times 13, and 13 times 5. So that's why I want to write this system of two equations. So let's start, for example, with the first one. So we have x plus y, 1 times 65. So we have x plus y equal to 1, and x minus y equal to 65. This is our first system of equation. Second system, we have, let's go with 65 and 1, so x plus y equal to 65, and x minus y equal to 1. This is our second one. The third system of equations, x plus y equal to 5, and x minus y equal to 13. And the last one, fourth, x plus y equal to 13, and x minus y equal to 5. Okay, so let's solve each of these system of two equations. First one, let's start. I'm going to write a solution right here to this system of equations. Let's start, for example, with the first system of equations. So let's add it. 2x equal to 66. This is a really quick method. 2x equal to 66, and from here x is equal to 33. But if you're talking about y, so for example we have y equal to x minus 65. Yeah, so y equal to x minus 65. So from here we have y equal to 33 minus 65, which is equal to minus 32. So basically we have one pair, 33 and minus 32, which is not good for us because we're interested in a positive value. We're talking about exponential equation with exponential function. So these both values need to be positive. So we reject this first one. Okay, let's go to the second one. The same thing, we're gonna add it. So we have 2x equal to 66. Okay, 2x equal to 66. And from here, x is equal to 33. And y, what about y? So y equal to x minus 1. Yeah, y equal to x minus 1. But y equal to x minus 1. So what do we have as a result? We have y equal to 33 minus 1 equal to 32. And basically, this is a great root for us, but I'm going to say a little bit later about this pair. So we have 33 and 32. 33 and 32. Okay, we keep it. Right now, let's solve the third equation. So the third system of two equations. So we have, right here, we have 2x equal to 18. Yeah, we have 2x equal to 18. And from here, x is equal to 9. But b, not like b, we have y equal to x minus 13. X minus 13, so equal to 9 minus 13 equal to minus 4. So basically, we reject this. 9 and minus 4 is not good for us. And our last step, we have fourth equation. With the fourth system of equation, we have this one, 13 and 5, so 2x equal to 18, so 2x equal to 18. From here, x is equal to 9, but y equal to, what do we have? Y equal to x minus 5. So as a result, from here we have y equal to 9 minus 5 equal to 4. So this pair is good for us. So we have 9 and 4. So right now let's solve our exponential equations. We have two pairs, 33, 32, and 9 and 4. Why the 33 and 32 is not good for us? Because we have two pairs. I'm gonna write it. So we have 3 to the power a over 2 equal to x, and 2 to the power a over 2 is equal to y. Basically, 32 is good for us because we are talking about 2 to the power a over 2 equal to 32. So basically, we can solve it. We can solve this part. A right here equal to 10. Yeah, a equal to 10. A equal to 10. But in the same way, we can't solve this part because 3 to the power a over 2 is equal to 33, so we can't express this 3 with some power as 33. So basically, we reject this second case. On the first side, it looks good, but we reject this part. And our last step, 9 and 4, our last pair. This pair is good for us, so let's split it. We have 9 and 4. This is our last hope. 3 to the power a over 2 is equal to 9, and 2 to the power a over 2 is equal to 4. So from here, what do we have? We have a over 2 equal to 2, a equal to 4. Yeah, we have a equal to 4. And 2 to the power a over 2 equal to 2 squared, so a over 2 equal to 2, so a equal to 4 as well. Yeah, so we have the same root, and it's really great. It means that we solved this question completely. So let's check it real quick. A equal to 4. So as a result, we have our equation 3 to the a minus 2 to the a equal to 65. From here we have 3 to the power 4 minus 2 to the power 4 equal to 65. 3 to the power 4 equal to 81 minus 2 to the 4 equal to 16, and as a result we have 65. So our root is absolutely great, and our answer a is equal to 4. Of course, you can solve this question by inspection method. You can easily do that, but don't forget about the other roots, because sometimes happen if you solve this question by inspection method, you forget about the other roots. And according to this method, you review all these roots quickly, you reject something, and you combine everything. You have 4 system of equations, you reject something, and that's why you can easily say that you solved this question completely without any problems. Also, write your thoughts in the comments below. It will be really interesting to read about it. It will be really interesting to read about your way, how you see the solution to this question. It's also really great to see it in the comments below. So thank you for your time. Take care of yourself. Have a great day. See you in the next videos.